So I'm gonna introduce my project which focuses on the application of advanced predictive analytics in traffic management. And this project isn't just about handling vast amounts of data, but leverage it to solve real-world problems that impact daily operations and strategic decision-making within law enforcement and traffic management sectors. And this is the structure of this project. So um, let's begin a project overview. And my project utilizes the PEMI08 dataset, which contains detailed traffic data uh, San Bernardino in the summer of 2016. All this data covers traffic flow, occupancy, and speed across 170 locations, gathered every 5 minutes. The goal of my project is to predict traffic occupancy rates, which are a critical indicator of traffic volume and congestion. So why I chose the occupancy? So this reflects the proportion of time that a detector is occupied by a vehicle within a given interval. And by predicting occupancy rates, we can identify potential hotspots of traffic congestion and optimize the patrol routine and schedule for law enforcement agencies, thereby enhancing public safety and resource management. So we use some technique approach and to tackle this challenge. I'm developing a predictive model using long short-term memory networks, a type of recurrent natural network that is well suited to modeling time series data. And this choice underscores the complexity of the problem due to the sequential nature traffic data and its non-linear patterns. So from employer's perspective, the evaluation of this project is being conducted from employer's perspective and focusing on three main aspects: the depth and the use case and the complexity. So now I will introduce the coding process. So now you can see that here we have this data formatting. Like we transform the NPZ data set to the traffic CSV, and we have this title, this timestamp, and location and flow, and occupy. And this is the data visualization, and you can see from here we have this plot here. And then we will go into the data preparation. So we do the data cleaning. First, we begin by cleaning the PMI's 08 dataset. This including handle missing data, outliers, and errors that might affect the accuracy of our predictions. And for example, I use the interpolation to fill in missing values and apply filters to smooth out the noise in the traffic speed data. And for the feature engineering, given the dataset feature flow, occupancy, and speed and energy additional time-related. Time-related feature to capture patterns uh, the peak hours. We have like the peak hours and weekdays versus weekends. You can see from here. And these features are crucial for our LSTM model to understand and thermodynamic of traffic. And also, we have model training here. The model setup. I choose an LSTM model for its ability to handle sequential data. Setting up the LSTM involves defining the architecture, number of layers, and and activation functions and so forth. For instance, our model uses two LSTM layers followed by a dense layer to output the predicted accuracy rate. And you can see that the running is here train the model. Like after And after fitting set model, we evaluate whether our model outfits the training set or not. One way is doing by plotting the loss functions and step loss plottings here. I can see like here. And also we have this evaluate the prediction. And to optimize modeling performance, I conducted hyperparameter tuning using techniques like grid search and cross-validation, focusing on parameters such as the linear rate, number of apples, and batch size. So I split the data into training, validation, and test set to ensure the model is robust and generalized well. Training involves feeding batches of historical data into the model, allowing it to learn from the past traffic patterns. And you can see from we have some RMSE and Spearman's post training. We contrast the prediction and the true value. As you can see from here, it is better than moving average and shows the model is not up underfitting, however. And the true test lies on the test evaluation since neural networks models it always overfit. So the conclusion is this government project aims to not only showcase my technical skills but also my ability to apply these skills to complex and real-world problems. The insights generated by the projects could help streamline operations and strategy in traffic management and law enforcement, and demonstrating the tangible benefits of data science in public sector applications. So thank you for considering the potential of this project. I look forward to discussing its outcomes and applications further.